Hey guys, Mr. Murphy here with another video lesson for you, this time dealing with exterior angles of circles. Exterior angles meaning here where the vertex is outside of the circle. For instance, on number 1, we see an angle of 45 degrees, and we're looking to find the measure of this little arc here from B to D. Cool. So if you watched my last video on interior angles, where the interior angle is equal to 1/2 the sum of the two intercepted arcs, you may also notice that these exterior angles, like C, have two intercepted arcs as well. One here at BD, and then let me get another color to show you the second arc. The second arc that is intercepted by the angle is this arc, AD. Arc AD is worth 150 degrees of your circle. Cool. So, for exterior angles, the mathematical relationship is very similar to interior angles. There's just one small difference. I'm going to go ahead and write it out for you now. Alright, exterior angle equals 1/2 of A minus B. Okay. So, exterior angle equals 1/2 of A minus B. In other words, the angle equals half the difference of the two arcs. So I'm going to put angle equals half the difference of arcs. And when we say difference, we're talking about subtracting two numbers. That's what we call the difference. Okay. So now, when I'm subtracting, it's got to be in a particular order, right? So, for exterior angles, A always refers to the bigger arc, and B always refers to the smaller arc. Okay, so for number 1, let's go ahead and find our arc. So I know my angle, my exterior angle, is worth 45 degrees. Equals 1/2. And then in parentheses, we're going to do A minus B. Now remember, A has to be the big arc, so I'm going to put 150 degrees first, minus B. The other arc that we're looking for is B. Okay, and then I'm going to solve. So what I can do to kind of start isolating that variable, letter B, is multiply by 2 on both sides to get rid of the 1/2. That cancels that out. 2 times 45 gives me 90. And that's going to be equal to 150 minus B. Okay. So now if I have 90 equals 150 minus B, I kind of want B to be positive. So before I do anything else, I'm going to add B to both sides to move it over here. So plus B plus B. This cancels. These are not like terms, so I can't add them directly. But what I can do is rewrite them like this. B plus 90 equals 150. And you see how with that step I've just made B positive, makes my life a little easier. Now the last thing I have to do is take away this 90, cross that out, and then B, the measure of the missing arc, is going to be 150 minus 90, which is 60 degrees. So this blue arc right here is 60 degrees. Cool. Alright, so this relationship is what you want to keep in mind when doing the other problems. Exterior angle equals 1/2 of A minus B. In other words, the angle equals half the difference of the arcs. Cool. Number 2 is another one like that, so I will go ahead and demonstrate. Again, we are looking for our missing arc right here. Let's call that B, because that's a smaller arc. We also have this 140 degree arc out here at arc PS. And then our angle right here is 45 degrees. So again, let's set that up. 45 is the angle, equals half the difference, so half. A, the big arc, would be out here, so 140, minus B, which is the little arc. Again, multiply by 2 on both sides. Cancel out the 1/2. That gives me 90 equals 140 minus b. Okay, now last time when we got here, I added b to both sides. You don't technically have to do that. Let me show you what it looks like if you don't. So if I move the 140 instead over to the other side, what happens is I get 90 minus 140, which is negative 50, equals negative b. And if negative 50 equals negative b, but really we want positive b, when I switch the sign here, I also have to switch this sign. So b is just going to be equal to 50 degrees. So either way you want to do it, if you want to worry about b last, or worry about your missing arc last, whatever. If you want to move it over to the other side and make it positive, that also works. Okay, now, with exterior angles, there are some special situations that come up that don't happen with things like interior angles. For instance, let's take a look at number 3. Number 3 is what happens when you have two tangents that form an angle. This is sometimes called a tangent-tangent angle. Creative name, I know. So, in this problem, ED is a tangent, and EF is a tangent. Okay. Now, with tangent-tangent angles, there arises a little bit of a shortcut to solving for them, but I'm going to kind of show you the long way first, because it will show us how to get to that shortcut. Now, we want to know the measure of angle E, and angle E is an exterior angle. Its vertex is outside the circle. So I can still do this 1/2 the difference of the arcs rule. Okay, so I'm going to set that up kind of off in this empty space. I'm going to do angle, so measure of angle E equals 1/2 of A minus B. And remember, A is the big arc, B is the little arc. Now, this arc right here, DF, that's the little arc, right? Now, what do you notice about the big arc? If you notice, the big arc that's intercepted would really be the remainder of the circle. And that's what's special about tangent-tangent angles. The little arc is intercepted by the tangent lines, and then the big arc, so to speak, is the rest of the circle. Now, I don't have the measure of that arc, but if I know that these two arcs make up the whole circle, I can do this. 360 minus 101. Now 360 minus 100 is going to be 260 minus one more would be 259. So this arc is 259 degrees around. Cool. Once I have that, I can find the measure of angle E. So measure of angle E equals 1/2. Big arc is 259 minus little arc is 101. Go ahead and do that subtraction. Keep the 1/2. 259 minus 101 should be 158. And then half of 158 is going to give you 79 degrees. Okay, cool. So with tangent-tangent angles, oftentimes you're only given one of the arcs because they expect you to realize, oh, hey, the other arc is just the rest of the circle. So do this, 360 minus the arc I have to find the remainder. Now, I want you to notice something cool. If I notice that angle E has a measure of 79 degrees, and I compare that to that 101 degrees, now obviously those numbers are not equal, but check this out. If I add them, 101 plus 79, it equals 180. And that number should stand out to you. Whenever we see 180 degrees in geometry, we kind of get excited, right? So with tangent-tangent angles specifically, the measure of the tangent-tangent angle plus the measure of the small arc will always equal 180 degrees. That's a little shortcut you can use if you have the arc and you want to find the angle, or if you have the angle and you want to find the small arc. Okay. All right, last but not least, number 4, I want to make sure I show you one involving algebra, just so you get the feel for how to operate that equation. Okay, so we're going to solve for x, and I see x in 2 places, arc dk and arc NL. And then to help us find that x value, we have the measure of angle M out here, which is 40 degrees. Since angle M is exterior to the circle, I'm going to use my exterior angle rule, which is this 1/2 A minus B, big arc minus little arc. Let's set that up. So I'm going to say angle M, measure of angle M, equals 1/2 of A minus B. Again, make A the big arc and B the little arc, like that. Plug in what you have. So measure of angle M is 40 degrees. 1/2 is part of the formula. The big arc is 160 plus 2x. And then when I do minus b, b is this little arc, this x plus 80. Make sure that you put that in parentheses. Anytime I'm subtracting something like x plus 80, you always want to put the subtraction sign and then your arc or angle in parentheses. And I'll show you why. So, when I'm looking inside the parentheses to do some of that math, before I subtract anything, the subtraction sign changes everything in this set of parentheses. So when I look at it, it becomes minus x, and then see how 80 is positive? If there's a minus sign out here, we're going to go ahead and change that to a minus 80. The reason I'm doing that is minus sign says we're subtracting both of these things. So now here's what I have in parentheses, and I'll bring down everything else too. So 40 degrees equals 1/2 of 160 plus 2x minus x minus 80. Now I can go ahead and combine like terms on the inside. Go ahead and bring everything else down. So if I do 160 minus 80, those are like terms, right? That gives me 160 minus 80 is just going to be 80. Now if I look at the x's, a positive 2x minus an x, remember this counts as 1x, so that's going to give me plus 1x, which I'm just going to write like this. So 40 degrees equals 1/2 of 80 plus x. Cool. Now, just like I've been showing in these videos, to cancel out the 1/2, I'm going to multiply both sides by 2. That cancels that. 2 times 40 is 80. And 80 degrees equals 80 plus x. Now, if I want to get x by itself, I have to subtract this 80 from both sides. Minus 80, minus 80. Now, this 80 cancels, leaving you with x by itself. And now, the 80s here also cancel, but since we need to have a number here, anytime that happens where I have that cancel out also, you get a 0. So in other words, x is equal to 0. And that can happen. If you plug x in, you will still see that the measure of the angle follows this rule when in comparison to the arcs. Okay. But yeah, so the x value here should be 0, and here's why. Alright, main thing with exterior angles to be cautious of. When you're plugging in the measure of the smaller arc, if it's not just a number, if it's something like x plus 80, make sure you do minus parentheses x plus 80. Otherwise, you might forget to switch those signs, and you don't want to forget that, okay? Alright. That's going to do it for this video. Thanks for watching. Hope this helped.